Okay, in the last video, we proved the spread lemma. So what we showed there is that if there's some subgroup that has a little bit of power in the sense that they're decisive about whether A is better than B, so if every member of the group likes A better than B, then not only that group, but the whole population likes A better than B, that if we give them that little bit of power, then actually they get to decide every question. They get to decide whether C is better than D, so if all of them like C better than D, then the whole population likes C better than D. And so they're, in effect, a kind of dictatorial group. If they're unanimous about a question, then they settle the population's opinion, the whole wide group, for any question. And now what we're going to show is that you can take that group dictator and continue to narrow it down and find a smaller and smaller subgroup until you end up with a single individual whose opinion settles every matter, and that's our dictator. That's how we're going to prove Arrow's theorem. So this is the contraction lemma. We start with a big group, maybe 4 of 100, and these 4 are decisive about every question, and then we continue to narrow it down until we get to 1. That's the contraction lemma. And we're going to proceed in roughly the same way that we did last time. It'll be a little bit more complicated. So it's going to be the same in the sense that we're going to look at a specific case, and then we're going to use axioms like the independence of irrelevant alternatives to tell us about what happens in other cases. So the same in that sense, but it's more complicated in that we're going to do a little bit of case reasoning here. Okay, so we're going to start with this specific case. So we've got maybe 4 out of the 100 that are decisive about every question, so maybe there are 100 out here, and we're imagining that they just have opinions about vanilla, strawberry, pistachio, and chocolate again, although we could do this with more than 4 options. And so this group of 4 is decisive about everything. So if they're unanimous about whether vanilla is better than strawberry, then the whole population likes vanilla better than strawberry. And in this particular case, person 1 has vanilla better than strawberry, that better than pistachio, that better than chocolate. Person 2 has strawberry and vanilla switch, so strawberries first, vanilla second, pistachio third, chocolate fourth. Person 4 has strawberry, then pistachio second, then vanilla, then chocolate. And then, that's person 3, and then person 4 is strawberry, then pistachio, then chocolate third, then vanilla. So these first 2, they switch vanilla and strawberry. They're the same on number 3 and 4. And the second 2, they're the same on numbers 1 and 2. They put strawberry then better than pistachio, but they flip around whether vanilla is better than chocolate. Okay, and then I've just copied this down exactly here because we're going to consider 2 cases. So what are the 2 cases? Well, one of the things that we assumed about the group, so I don't know just from looking at this whether, for example, the whole group, all 104 of them, like vanilla better than pistachio, so 2 of these members like vanilla better than pistachio, the other 2 like pistachio better than vanilla. What is the group like? Well, Pareto, for example, doesn't tell us anything about that. But we do know that the group overall has some opinion or other, and so we're just going to consider the 2 cases. So case 1 is the case where the group likes vanilla better than pistachio. And then case 2 is the case where this group turns out to like pistachio better than vanilla. Okay, so they have some opinion about the matter, and then we're just going to consider, in either case, what must follow from that. Okay, so at the outset, note that there's some agreement in this group. So start with case 1. There's some agreement in this group. So in particular, everybody likes pistachio better than chocolate. And because they're decisive, these 4 settle that matter for the entire group, all 104, or 1,004, or 1,000,004, however many there are. And so, in particular, the group must then like pistachio better than chocolate. And then because group preferences must be transitive, what this gives us is that vanilla must be better than chocolate. Okay, so far so good. Now note that if this is the answer we get in this case, then this is the answer that we must get in a wider range of cases. So in particular, let's consider cases where we change around the preferences of persons 3 and 4. So let's say we flip around person 3's preferences for vanilla and chocolate. So they like strawberry than pistachio, first and second still, but now they like chocolate better than vanilla. Or we flip around person 4's preferences over vanilla and chocolate. So now they like vanilla third and chocolate fourth. Now we can run the exact same argument in this case if we swap in this or if we swap in this that we just ran a second ago. So because in any of these cases we still have pistachio better than chocolate, so we've got pistachio better than chocolate across the board, then we must have pistachio better than chocolate here. And notice that we haven't changed the ordering of vanilla and pistachio. So we still have vanilla above pistachio for 1, we still have vanilla above pistachio for 2, and so we haven't changed those at all. Here we changed around the ordering of chocolate and vanilla, but we left pistachio above vanilla. And here we changed around vanilla and chocolate, but we again left pistachio above vanilla. So by the independence of irrelevant alternatives, if in the first case we had vanilla above pistachio, then because we didn't switch around vanilla and pistachio at all, we must still have vanilla above pistachio in this case. That's what the independence of irrelevant alternatives tells us. So what do we have? We still have vanilla above pistachio. We still have unanimity amongst this group for pistachio above chocolate. And so the entire population must like pistachio better than chocolate. And group preferences are transitive, so we must still have vanilla better than chocolate. Okay, but now, for the final trick, notice that the group preference, the overall population's preferences for vanilla over chocolate, depend only on how individuals rank vanilla and chocolate. And so what independence of irrelevant alternatives tells us we can do is, if you end up with vanilla and chocolate in the cases, vanilla above chocolate in the cases we've considered, then you can erase pistachio and strawberry in all of these. And you can put pistachio and strawberry wherever you like. That will not affect the ordering of vanilla and chocolate. So in every other case, however these individuals order pistachio and strawberry, as long as you keep these rankings of vanilla over chocolate fixed, so these two like vanilla better than chocolate, you'll get vanilla over chocolate for the group. And notice that however person 3 ranks vanilla over chocolate, whether they put vanilla on top or chocolate on top, and however person 4 ranks vanilla and chocolate, whether they put chocolate on top or vanilla on top, as long as we hold these first two fixed, they both rank vanilla over chocolate, we'll get vanilla over chocolate for the group. And that makes these first two, this subgroup, that makes them decisive about the question of whether vanilla is better than chocolate. So originally we started out with this big group being decisive about every question, and now we've shown that in this case, this subgroup 1 and 2 must be decisive about this particular question, whether vanilla is better than chocolate. But notice that we just proved in the previous video that if you make a group decisive about one question, then they end up being decisive about all of them. So actually, this group will turn out to be a dictatorial group. They'll be able to be decisive about every single question. So in case 1, 1 and 2 end up being a dictator. Now we'll be able to run exactly the same kind of argument in case 2 to show that there's some subgroup that is a dictator. So let's imagine we're in case 2 now. So instead of having it be that the group likes vanilla over pistachio in this case, we assume that the group likes pistachio over vanilla in this case. Okay, now what can we conclude? So again, remember there are maybe 100 other people out here, but we're assuming this group, this subgroup, is decisive about every question. And notice that because they're decisive about every question, they're decisive in particular about whether strawberry is better than pistachio. And now go down the line. Just look and see everybody likes strawberry better than pistachio. And because this group is decisive about whether strawberry is better than pistachio, the group must like strawberry better than pistachio. So let me put that up here. But now, notice that we've got this chain. Strawberry than pistachio, pistachio better than vanilla. And so the group, because group preferences are transitive, the group must like strawberry better than vanilla. And now, note that we can run exactly the same argument if we flip around the preferences of 1 and 2 a little bit. So, instead of having these exact preferences, one could have had, they could have had, instead of vanilla, strawberry, pistachio, chocolate, they could have had strawberry, vanilla, pistachio, chocolate. Strawberry, vanilla, pistachio, chocolate. So that's another way things could have gone. And instead of having these preferences, we could have had them switch around vanilla and strawberry, so they could have had vanilla, strawberry, pistachio, chocolate. And note that in this case, we would have been able to run exactly the same argument. So we could have looked across the board and noticed that all of them still like strawberry, whether we ended up here or here, here or here. They all like strawberry better than pistachio, and we haven't fiddled with these at all. And so because this group is decisive about that question, the group will end up liking strawberry better than pistachio. And notice that this group the group preference for vanilla over pistachio, pistachio over vanilla, they must still like that. Why? Because that preference only depends on how these individuals rank pistachio and vanilla, and we haven't changed that at all. So in the first case, person 1 liked vanilla better than pistachio. Well, this little fiddling didn't change that. They still like vanilla better than pistachio. And person 2 liked vanilla better than pistachio, and we haven't changed that here. They still like vanilla better than pistachio. And we haven't messed with these at all. These people still like pistachio better than vanilla. So in this case, because each individual still ranks vanilla and pistachio the same way, the group, independence of irrelevant alternatives, tells us the group must continue to like pistachio over vanilla. So, with all of these fiddlings, we still have strawberry better than pistachio, we still have pistachio better than vanilla, and so the transitivity of group preference forces us to forces the group, the population as a whole, to rank strawberry over vanilla. And now for the final trick. This is the same final trick that we saw last time. What the independence of irrelevant alternatives tells us in this case is that the whole population's ranking of strawberry and vanilla depends only on individual rankings of strawberry and vanilla. So I can actually go through and I can erase the non-strawberry vanilla options. So erase pistachio and chocolate. Erase pistachio and chocolate here. Erase pistachio and chocolate here and here. And what am I left with? Well, what we see is that whether or not person 1 ranks strawberry over vanilla doesn't matter. Whether or not person 2 ranks vanilla over strawberry or strawberry over vanilla doesn't matter. As long as we hold fixed that people 3 and 4 rank strawberry over vanilla, we'll end up getting that the group ranks strawberry over vanilla. And that makes this subgroup, 3 and 4, decisive about the question of whether strawberry is better than vanilla. But in the previous video, we saw that when we proved the spread lemma, that making them decisive about a single question actually has a really big effect. It makes them decisive about every question. So in case 2, 3 and 4 actually must be a dictatorial group. They must get to settle every single question. So either way, I mean, we end up with different groups in case 1 and case 2, but however things shake out, there is some subgroup that is a dictatorial group. So if we ever make a subgroup dictatorial, we get to keep finding a smaller subgroup that is actually dictatorial, however things shake out. And to conclude Arrow's theorem, we just note that the whole group, 104 or 1,000,004 or 1,000,000,004, however many there are, they, by the Pareto principle, are a dictatorship. So if they all agree, Pareto says, the group must have that same preference. And then we just apply this contraction lemma over and over and over again. So you start out with that 1,000,004, and the contraction lemma says there must be some smaller subgroup that is, in effect, a dictator. They're decisive about every question. And then you apply that contraction lemma again, and there must be some subgroup that is, in effect, a dictator. They are decisive about every question. And do that over and over and over again until you get down to a single individual, and that person is your dictator. And that is the proof of Arrow's theorem.